Welcome back. Before we get too deep into implementation, it's worth asking, where do we draw the line between what goes in the model and what goes in the controller? What's a good way of deciding where our functionality should go? This is a common question when working with larger projects that benefit from following patterns like the model view controller in a consistent way. Ideally, we don't want our controllers worrying about how the data in the model from our MVC pattern is stored, whether that be in a database somewhere in the cloud or in memory, like our launches model in our map. Ideally, our controllers can focus on working with the request and the response, and our models can give us these data access functions, which control how the data in the model can be written to and read. Let me show you. Rather than exporting our launches directly, which means that our controller now needs to know that our launches model is a map, which we need to first get the values from and then convert into an array, it would be better to abstract this implementation detail away. What that means is that the controller only needs to know that we're using the launches model, and from that model, we're getting all launches, which is a data access function that we will export from our launches model. And now we have a naming conflict where our controller and our model both have functions of the same name. This happens, and we can deal with it by either being explicit and not destructuring. So we could say launches model and do launches model dot get all launches. Or another pattern that you might see, if you still want to make use of all of the benefits that destructuring gives you, we can be more explicit and call any function that works with our HTTP request and response an HTTP function by saying HTTP get all launches. Now we know that any function starting with HTTP returns a response, and we need to update our exports as well as our app.js, or rather our router.js, to use our newly named function. Now, in our model, we can keep our launches map as an implementation detail that the rest of the world doesn't need to know about. And instead, we'll export some functions, like getAllLaunches, which takes no parameters and returns the launches in the format needed by our controller, converted to an array. Finally, we export our new data access function. It doesn't have to be complicated, but we'll really feel the benefits of this as we write more code. When we use models with these data access functions, there's a clearer division of responsibilities between the model and the controller. Our model only ever works with the data based on however it's stored. Now compare that with our controller, which only ever uses these data access functions to work with the data model and to put it all together into a response that's useful for our front-end client. Let's quickly apply this pattern to our planets controller, where we'll use this get all planets function from our planets model, and we'll use HTTP get all planets to access our controller function. So now in our router, we need to make sure that we're always using HTTP get all planets and not the function from the model. Now in the model, we'll create this function, get all planets, which just returns our habitable planets array. And now we can export only our data access and any loading functions from our models without worrying about how the data is stored. Oops, and I think I forgot to call our getAllPlanets function here before we return the result as JSON. I promise we won't be doing too much of this moving of functions around after we get a solid structure for our code. But it's really worth investing in if you plan to keep working on your project for more than a day or two. Definitely, if you're working as a software developer, spending a little bit of time to structure your code is worth the effort. To put what we've learned into perspective, our data access functions are part of what's called a layered architecture, where our applications consist of multiple layers which talk to each other. We can separate our application code into these layers either standalone or in addition with the MVC pattern, where, for example, our data access layer with our data access functions is very closely related with our model. And our business logic will then be the controllers that respond to HTTP requests. And our user interface is like our views. Sometimes it helps to look at our project architecture from the perspective of layers as opposed to models, views, and controllers, and to combine them like we've done with our NASA project. In general, application layers are part of a design principle known as separation of concerns, where we want each part of our project, each module, to be responsible for one thing and to do that one thing well. The more different concerns we mix between modules, the more complicated it is to keep track of all of the changes that are being made and all of the relationships between the different components. Separating our concerns makes our code easier to understand, easier to update, and easier to grow into a much larger, more impressive piece of software. And with that, let's get back to our project. I'll see you in the next one.